Hello everybody and welcome back to the Ultimate Power Tool Workbench series. It's been a while. I hope everyone had a lovely Christmas, New Year, festivities, celebrations, whatever. It's time to get back into the swing of things. We've got a few bits to update you on, so let's get going. So I finally got round to picking up the Valcromat for the top of the workbench. Originally I was going to go for blue, similar to the colour of my floor, and in all the plans that you've seen prior to this video it has shown a blue top, but when I got there, stupidly, I didn't actually check what they had in stock. I did that age-old thing where you turn up and expect that something's in stock. Not that I got aggy or anything, I've been that side of customer service before and I know how annoying it is when customers do that. Stop going off topic, Matt. You're out of retail now, calm down. But fortunately, the last one they had in stock, which was actually a discrepancy on their system, was dark grey. And to be honest, this was my second choice all along. The main reason I was going for blue was to kind of just try and add more colour to the workshop, because for me, I quite like black, as you can see. Painting the floor blue. Oh my Jesus Christ. Painting the floor blue was quite a push for me, but yeah, we're sticking to grey for the top, and it also helps with the camera as well in terms of the white balance, so I'm sure I'll be thankful for it. And also the added nice thing about dark grey is that any wood chips left over on the surface show up very easily, whereas I don't think it would blend into blue as much. But yeah, it means that I'll be able to see any stuff laying on there and just brush it off before I put my nice flat panel on there so it's not rocking side to side, which is very nice. I'm happy with grey, that's fine. Now the other thing I noticed, which is fortunate because I didn't want to assume anything, is that the panel is 1222 millimeters wide. Normally a sheet of MDF, plywood, man-made board, whatever, would be 1220. So this is an extra 2 millimeters wide. And in terms of length as well, let's get that over there. Got a decent tape measure now, by the way. This is 2445, where normally it would be 2440. So the length has got an extra 5 millimeters on it as well. And by the way, in terms of tape measures, I know I said that I'm like never going to use them again, but this one is one that I bought back in, like when I was in Wood, but I lost it while I was there. And this is by far the most accurate tape measure I have ever used. And this is not a sponsor, this is genuine recommendation for you. They come in 3 meters, 5 meters, and I think 10 meters. And it has a few different features as well. It's got a really strong lock on it, so you've actually got to push the trigger in order to bring it out, and that is like rock solid on there. It has also got a marking gauge on it as well. So you hook this over the bit of timber, and then on the bottom here is a really sharp point that you can drag along the work. So you can basically set the scale of this to, what's that, 90 mil? 90 mil. And then it's got a scratchy thing underneath. So you hook it over, drag it back. It can also measure, hard to do one-handed, internal dimensions by unwrapping that back bit. And what that does is adds 100 millimeters onto the scale here. On the back of it, you've got a diameter thing, so it looks like inches. It is not inches. You basically wrap this round, a round thing, and something to do with pi. I don't know what it is. I studied GCSE maths a long time ago, but you can wrap this round a round thing and it will measure the diameter of that round thing for you. Just like this. There we go, round the pillar drill column. There we go, round like that. It's got a little pointy arrow going up from that bottom layer, and this is pointing at 93 millimeters. That means that the column is 93 millimeters in diameter, which is something you couldn't accurately measure beforehand. So yeah, I'll put links to it in the description. It is the Hultafors towel meter. These will be affiliate links. Like I said, this video isn't sponsored by Hultafors, but by using those links and buying the tape measure, I get a small commission from it, which I'd be incredibly thankful for. January is a bit of a dry month, so yeah. Anyway, back onto actual work. As I said, this panel is oversized, and on the back here, there is a big old dent on the corner of it, which they knocked off some money for me. And now I just get to cut it off anyway. I'm such a con artist. Anyway, let's cut this down. All right, so that's cut to size now, and now it's time for me to have a quick cleanup because I need to start cutting timber to size to go around this top and for the supports in the middle. Now, we've had a bit of a design change with this for various reasons, which I'm going to pass over to future Matt while he is editing this video to explain all of the details. So over to you, future Matt. Why, thank you, Matt. That's very generous of you. I hope you're enjoying your cold workshop while I sit here in the lovely warm comfort of my office. Anyway, I'm just going to break it to you. This is what it used to look like, and this is what it now looks like. Now, those of you familiar with Ron Pork will probably recognise this. It looks very similar to the top on his workbench. And no, this is not intentionally a direct copy. In fact, this isn't even a direct copy of it. It is simply the best solution functionally and aesthetically. Let me explain. So the problem I had with the original top design was future-proofing my stupidity. If I was to drop a little thing down one of those holes in the centre of the table, that's gone forever. It's been dropped into a cavity, and unless it was magnetic, I pretty much had no hope of getting it out at all. So that's why the open-sided design works so well, because you can just get your hand in the side and take anything out of those cavities. And this is why it looks similar to the pork bench, because, you know, I could make those cutouts square, but that would probably just look a bit rubbish, whereas it's very easy to make that nice and round and sausage shaped. Why wouldn't you do that? That is the only reason it looks similar, because functionally and aesthetically it works. The other problem was working out how to attach the top to the supports within the torsion box. I've been trying to work out a solution for the entire series and decided to settle on screwing it to the top. The issue with screwing it is because this top was due to have plunge saw cuts and maybe even router cuts in the top of it if I'm being careless, having a screw in the top surface, a metal screw against a metal cutter is not going to go well. So the obvious solution there would be to counterbore it. That brings the screw below the surface, then it can't get hit by any blades or bits or whatever. It would also mean that the top is removable. However, because I'm dominoing the skirt to the sides, the top cannot be removed. It will be fixed in place. And because of that, there's no point having those screws exposed, so you could just plug it with a dowel on top. But then the issue is, well, hang on, that top is going to look pretty ugly now, because there's going to be all these random dowel holes over it. There's going to be holes for the path dogs and things like that. It's just going to look a right old mess. Nothing's going to line up. So then I was chatting to my old work colleague Tom at Axminster, and I don't know if it was sarcastic or jokingly, but he said a sliding dovetail. Yes, that would be incredibly difficult to pull off. Yes, it would be an absolute nightmare to cut, but it would be a good challenge to start with, and it would pull the top in tight to the supports within the torsion box, and there would be no metal fixings in there at all. So here's the new design of the workbench. This is the version I'm working on, which will be available at the end of the series. If we look at the end of it, you can see that the central support is dovetailed into the top. Now this is an 8-foot sliding dovetail, and that is going to take some mashing to get that in. Bear in mind that this only needs to be dovetailed to the top, because that's the side that's going to have all the cuts and things in it. The bottom can simply be screwed in place, and it would be a nightmare to try and get both of those components aligned while pushing the sliding dovetails in. And then moving around to the front of the workbench, there's going to be 3 supports here that are conveniently placed so they don't clash with those front cutouts on the workbench. There'll be 3 of those, and there'll be 3 on the back, which will slide in and hit that middle support, and these will be roughly 2 foot long. Hopefully a little bit easier to push into place. And that is the overall design of the new top. Back over to you, Matt. So originally I cut these bits of timber to be the skirt round the outside of the top, but now they are too narrow to be that component. But fortunately they're at the perfect length to become the sliding dovetail sections supporting the top. So that's what these will be, which means I need to machine up new bits of timber to be the skirts on the workbench using these 12-foot boards of yellow pine that I've just gone out and bought again. Oh boy. All right, so now it's time to cut the dovetail in the underside of the Valcromat top, which is going to be terrifying. So we've got a dovetail cutter to do that, but it is an accident waiting to happen if you just go straight in with this thing. It's a lot of strain on the router, it's a lot of strain on the actual bit itself. You just don't want to go full depth of this thing straight away, much like any router bit, to be honest. You want to do it in a series of successive passes. So to begin with, because you can't do successive passes with a dovetail bit, because it just doesn't create a dovetail that way, I'm going to go through with a solid carbide router bit, get almost down to full depth with it, and then we'll switch it to the dovetail cutter, and that will finish things off nicely without too much strain on everything, including myself. But the thing to bear in mind, if you are doing this after this project is posted, or if you're making this thing after me, you do not want the sliding dovetails to be directly below where one of the dog holes is going to be on top, which requires careful planning out, careful marking. Everything will be listed on the plans at the end of the series. So if you want to build this after me, all the hard work will be done for you. Right, where do I start? All right, everything's marked out on the Valcromat. Now it's time to attach the router to the Starship Enterprise. Okay, so I've got the track into position. It is a 25mm offset from the center line of this board where I'm going to be cutting the sliding dovetail. 25mm isn't the standard offset from this thing, but it's within the side-to-side adjustment of the guide rail adapter itself. Right now, I'm just waxing the strip on the guide rail because I do not want this thing shifting. I've never had it move on me while I've been using it with the track saw, but the track saw tends to, because the way it cuts, it doesn't really allow a lot of side-to-side movement, whereas a router, that can cut in any direction it wants. So if anything, there's slightly more of a possibility of this track moving. And this is just a precautionary measure that I'm taking, but really the grip on the bottom of this is very good. Okay, so the depth of these dovetails is 8mm. So I'm gonna set this straight cutter to cut 7mm. Oh, I should have done this before I put it on the floor. Okay, here goes nothing. This could be 70 quid down the drain. I think that was rather successful. Okay, now, do I do the dovetail cutter first, or no? I want to do all of the straight cuts first and then swap to the dovetail cutter. The reason is, if I do the dovetail cutter now and then switch back to the standard straight cutter and remove some of the cross ones here, then go back to the dovetail cutter, those dovetails are inevitably going to be different depths. And when it comes to cutting the male part of the dovetail on the router table later on, those are going to be locked in at exactly the same fence settings and everything. So if I make it fit one of the dovetails on here, it may not necessarily fit the others. So basically, we're going to trench it all out first, do all of these straight cuts across this bit of Valcromat, and then we'll go over them again with the dovetail cutter to ensure they're all at exactly the same depth. Okay, so that went pretty well. There was a little bit of side-to-side movement on the guide rail, but ow, that hurt. But luckily, I spotted it. I managed to get, what am I even doing here? I managed to get quite a good system at the end of it where I started on the inside of the board and then moved outwards, and then that way I could actually just put my body weight on the rail itself and prevent it from moving. Because now we're doing the dovetails, this cannot move side to side, up and down. This needs to be in exactly the same position along the entire length of the board. Otherwise, the dovetail will not fit and it will be a complete waste of my money and time, of course, and effort going to get the boards. So really, I don't want to screw this up, but this is just one of those things where you got to bite the bullet and go for it, which is what we're going to do. Okay, so this is a bit of a tricky one because, as I said earlier, when I'm cutting this dovetail, I don't want the router to be moving up and down at all, because if you move it up and down, then it will change the shape of that dovetail joint, which means that ideally, if I want a constant dovetail all the way through this, I need to start off the end of the timber, plunge it down to full depth, pass it through, and then bring it back out. But if I do that, then I push the router down on the overhanging part of the guide rail, and that will cause the rest of it to like wheelie up, and then it will flop back down in the incorrect position. So to get around that, what I'm going to do is plunge the router in the center of this Valcromat top. That will create a circle that is wider than the rest of the dovetail, but it's not too much of an issue, to be honest, because it'll only be a small section of the dovetail that isn't correct, but over the whole length, you're not going to notice it as you slide the male section into this, hopefully. Just going to go for it. I think this is the time for suspenseful music, isn't it? Yeah. There you go, you can see the entry point there. So it's just a little bit wider than the rest of the dovetail. But to be honest, when it's sliding through, then it's not really that's not gonna affect it at all. In fact, not that you'll ever see it anyway, but the shoulders of the dovetail are gonna hide that. So yeah, that's okay. Cool. So that went well. I had a thought. A question that some of you may be thinking is, Matt, if you were so worried about the placement of those grooves in relation to the holes on the top, why didn't you just drill the holes in the top first and then work around that? To be honest, I don't really have a proper answer for that. For me, I would just rather get everything in place first, as in this entire top assembled, before drilling the holes. That way I can just see it all in situ, and I don't know. I really don't know, to be honest. So if you were thinking that, congratulations, that is probably a more logical way of doing things. Yeah, that's all I've got to say. But anyway, this went really well, which is nice. All right, so now comes time to cut the male parts of the joint, which is probably the most difficult bit because you've got to contest with the height of the router bit and also the offset of the fence from the router bit as well. So usually when I'm setting up the router table, I'll set the height first, and then you could just tap the fence back and forth to get the right width of cut. The issue with testing the sliding dovetail is that in order to cut both sides of the dovetail, normally when you're setting up a router table, you can just sort of take a little nip and then test it against something. However, with this, because we've got to do both sides of the dovetail, if I slide it up and cut that side, I can't actually get to this side here unless I was to come from this way, which would be a reversing cut on the router table, and this thing would just like shoot out this way because you want to be cutting against the rotation of the router bit. That means that when you're setting up one of these, you're going to go through quite a lot of material because you need to go all the way through and then flip it round and then go all the way through that way. It's not a case of just being able to nip the end of it, unfortunately. So to get the height of the router bit, I'm going to get a marking gauge and then drop that into the sliding dovetail that I've already cut, push the stock up to it, make sure everything's firmly in place, and then carefully lock it down. And then on the end of the bit of timber, with the side facing down, I'm going to score that marking gauge line along here. Now this is just a guideline. This isn't going to be the final depth. I might get it spot on, but it's very unlikely. Easiest way to do this is start the router bit a little bit too low and then bring it up to the height of that, and that gets rid of any backlash in the thread as you're rising and falling the router bit, and it's less likely to shift on you. Right, it's about 1 millimeter too low at the moment. I'll probably get it a little bit closer than that. All right, I'm going to set it there to begin with. Okay, so now we'll set up the featherboard. That will give it a firm amount of pressure pushing into the fence. Makes it less effort for me as well. Cool. Right, let's run it through. Okay, and then with that, I can just sort of test it on there I can see that that shoulder is just interfering with that top face, which means we're not quite up to height yet. Not far off though. All right, so I'm pretty happy I've got the height. Just need to sort out the offset of the fence now. So to begin with, we're going to make this way too shallow of a cut, and then I'll test both sides of it to create the dovetail shape, and then test that, see if it's too wide, and then knock the fence back a bit, retest it, and just keep doing that over and over again until we get a lovely tight fit. All right, so I've achieved a very, it's not tight, but it's snug. And if it was a sliding dovetail that was of a normal length, i.e. not 8 foot long, I'd be very happy with that fit. However, I slid this in about 2 inches and it already started to bind. Over that distance, that's going to take a lot of whacking to get that in. So I'm going to take a little bit more off this and make it, just hopefully make it slide in a little bit easier. Bear in mind that when you're making adjustments with a router table fence and you're doing both sides of the piece, any adjustment you make on here is doubled. So if I move this back 1 millimeter, if you take 1 millimeter off both sides, then you've taken off 2 millimeters overall. Pretty obvious to most people, but when you're making that adjustment, just bear in mind that you want to take off really small amounts. Like I want to take off 0.25 of a millimeter at the moment, which means I need to take off 0.0125 of a millimeter. Like, I'm not going to do that, but you just need to be very, very precise when doing this. All right, so remember what I said at the start of the series, maybe episode 2, where I said, don't always trust your cutting list because you want to be measuring off the actual piece rather than off the diagram that shows the ideal measurement. I should have listened to my own advice there because I went ahead and pre-machined something that is now not the correct size. That is the front, well, not the front skirt, the front, side and back skirt. I thicknessed these to 122 millimeters when actually the size needs to be 124 millimeters. Hence why we've got all these clamps out. I have got spare yellow pine to cut, like if I wanted to do more, but I've got some really nice bits here and I chose these specifically to go around the workbench. So all I'm doing is, I've got these little like battens that I'm basically sticking on. These are scraps from another board of the yellow pine. Stick it on like that, and then we'll re-thickness it down to the correct size. So while that is drying, I am going to get started making templates for the oval thingies that are going like round the skirt on the top. So these are 75 millimeters tall and, oh, what a horrible sound, and 400 millimeters wide. So I've got two crosshairs that I'm going to drill out with 75 millimeter hole saw, and then I'll somehow clean out the rest of the waste, probably with a chisel again. Okay, so it's now the next day and these are all glued up. So let me explain to you the actual order of operations you should be taking for this. First, you do that, then you do that, then you do this. And now, would you believe, it fits perfectly. You stupid idiot. Okay, so for the corners on this skirt, I've been playing around with different ideas. A butt joint would be the simplest option. One like that, bang, done. But then you get a bit of end grain on there, and that end grain isn't gonna line up with the leg when it goes up. And keeping with the theme of overcomplicating everything we've done here, like I've just done an 8-foot sliding dovetail, for God's sake. We're gonna do a lovely, simple mitre joint on the corner of these. I bet you thought I was going to say a dovetail then, didn't you? I'm not that... No, I'm not going to do a dovetail. Mitre joint, which means to cut the mitre joints accurately on the end of these, I need this to be fixed at the exact position where I want it to be, which means going back to our old trusty friend, the domino. Now, I know a lot of you got aggy in the last episode because apparently I said domino a lot. Domino, 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 dominoes, domino lines, domino, domino slots, domino, the domino here, the domino, dominoes, domino that, domino in there, domino, it's dominoes, domino hole, domino, it's domino. Oh, okay. But anyway, on the corner, I want the mitre joint to be starting exactly on that corner, and when it comes to marking out the other side, oh, it's wakey time. Basically, I want to mark this mitre and mark the other mitre without them shifting at all, and also glue them in place without it shifting. So normally when you're putting dominoes along a long edge like this, you don't want them all to be on the snuggest of settings, because then you're relying on all of those to be bang on when you plunge the domino. But if one of them is slightly off, then that is going to restrict probably the entire component from being pressed in properly. So to get around that, the domino provides a setting where you can create a slightly wider slot, and that is perfect for edges like this. However, if I do that all the way along, it means that this skirt is going to be able to shift side to side while the glue is drying, and I don't really want that. I want it to be in one position, and that is that. So to get around that, I'm going to do a mixture of both of them. We're going to have some that are snug fits and some that are a little bit loose. Probably going to do 4 that are snug fits, and then the rest of them will be loose. And that way I've only got to align 4 of them perfectly. The other ones can sort of have a little bit of side to side movement in the slot. And those 4 that are perfect will be the ones that hold this in place and prevent it from moving. So to begin with, I'm going to clamp this skirt in place, making sure that I've got an even amount of overhang either side, just to make sure I can fit a mitre on there easily. Wait, I've just had a thought. The MDF on the bottom of this is still loose, which is going to make it a bit of a nightmare when flipping this over and realigning everything. If I clamp these skirts in place with this top upside down, that will give me the exact location of where that MDF top needs to be sitting on the cross supports below, and then I can just screw it in place. Then it's fixed. Because doing it this way is going to involve a lot of juggling. Oh, I've got to flip this top over, haven't I? Oh no! And now I clamp the skirt in place, and this will be in the correct position. Okay, so I've got the centerline and drill locations marked. Bob popped round a couple of weeks back and dropped me round this thing. Now, I've never actually had a go with a combined drill and countersink before, in all honesty. I have always done it separately because, to be honest, the work that I do doesn't always require a lot of screwing and countersinking unless it's a back panel of a cabinet or something like that. I've rarely needed to do large amounts of it. But obviously for the bottom of this table, this is going to take a lot of drilling, a lot of screwing, a lot of countersinking, whatever. So I'm going to try this thing out. It is a drill with a countersink built into it, but you slide that up, flip it round, and then you can put a hex bit in the end of it there. So this should speed things up pretty quick. Comes in a box. There's loads of different size countersinks and drills, and I think you can interchange them maybe. Yeah, it looks to be just a standard drill bit that will fit in there. So we're going to give it a go and see how much time it saves. All right, remember that thing I was doing earlier about putting the dominoes in? Yeah, now it's time to actually do that. So I've been having a think, God forbid, and I've thought maybe even 4 snug fitting dominoes would be excessive. Like, all I really need is this one to be fitting snug, because that means that when the mitre's cut into here, that can't move at all because it's restricted by this. Maybe one in the middle as like insurance, and then one at the other mitre end, obviously. Other than that, all these other ones can have a little bit of side-to-side movement in them to help with alignment. Okay, here we go. Right, so now I need to flip this over and domino the Valcromat side of things. All right, so both sides are fitted. It works, which is good. So next I need to cut those oval thingies that are in the faces of the table. Once I've done that, we're going to mitre the ends, then I stick this in place. Once that is dried, that is when I'm going to be fitting the mitres or the ends of the tabletop on, because then I can get the perfect fit between the 2 mitres cut at either end. So on this trusty bit of paper, I've got all the measurements I need for the spacings of the holes. So I'm going to transfer that onto here. All right, it's looking rather good, if I do say so myself. Everything lines up, as in like the cross support things here do not line up with the holes. Everything is out the way, so yeah, it's looking good. Now it's time to sort out the miters. So as you can see, I've got everything dry clamped in place, and all I'm gonna do is put a little knife mark on the top there. I've actually already got a pen mark there, but a knife mark gives a more definite line to work to. And then the other thing I like to do is draw on which way I'm cutting the mitre, because it would be very easy to accidentally cut the line going this way and mitre it the wrong way. Always draw the mitre on there. So you've always got a visual cue as to what way to angle the blade. Then I'll just carefully score these across, making sure that line is really precise. I don't want to be doing multiple cuts of this. I kind of just want to get it done in the first hit, to be honest. Although I do trust the scale on the back of this mitre saw, I'm still going to use the little bevel box on it to get this at spot on 45 degrees, just for insurance. Okay, so the clamps have been on here about an hour now, and between picking glue off my hands, which is definitely up there with my favourite hobbies, I have been shifting the clamps around every time I see a new gap open, because I've only got 4 that will actually stretch that length, so I kind of need to work with what I got. The glue has hardened enough now that when I push a new gap shut, and then I sort of take the clamps off a minute later, it stays where it is, and I'm pretty sure I have closed up all of those gaps now. It's looking pretty good. I've got some blocks here as well, and a block up that end, which is helping to spread the load even more. Yeah, it's looking pretty good. So I think I'm going to call it there for this episode, because quite frankly, look at the state of this workshop. This is disgusting. So I'm going to leave the glue to dry, and then we'll get attaching the ends in the next episode. So of course, thank you very much for watching. If you liked the video, don't forget to press the like button and subscribe if you haven't already. It'll take you 2 seconds and it will help me massively. And of course, if you're sick of watching projects and you want to know more tutorials, or you want to see some reviews on some of the kit I've got knocking around, then have a look at my website. Link to that is also in the description, and you'll easily be able to browse all of the videos I've filmed over the past couple of years. Yeah, thank you for watching. See you in the next video.